Hello, my dear class 10 students, welcome back. So today we will start a new chapter from physics portion, that is chapter 12, current electricity. Okay, current electricity. Now electricity is very important, right? We are all dependent on electricity in our everyday life, clear? Now electricity, it can be, we can study in two types, that is static electricity and current electricity. Current electricity. Clear? Now this, electricity is all about the charge, the flow of charge. Okay, without the flow of charge, there won't be any current now. Clear? So it's about the flow of charge. Now static electricity means, in a simple word, it is charge at rest. Clear? So we are not going to discuss about this, okay? We are not going to discuss about this. We are going to discuss about the current electricity. Now current, if I say current, means something is in motion, right? Okay, motion. So this will be the opposite of the charge at rest. That means this is charge in motion, right? So students, see, electricity in a general term we can divide in this way, that is static electricity and current electricity. You'll study about this in your higher classes in class 12, 11 physics, but now we'll study about this one, okay, about motion, okay, current electricity. Okay, so students, now under this, see, I want you to remember two things, that is insulator and conductor. Okay, so what is insulator? Insulator will come under this one, okay, static electricity. Insulator means materials, okay, materials that do not allow charges to flow through. Okay, suppose this is it can be non-metals, okay, it can be rubber, it can be plastic. All these are what? Insulator, because they do not allow charges to flow through. Okay, so here there won't be any electricity because there is no flow of charge. Okay, but what about this conductor? Because current electricity means it is to do with conductor. Clear? Now conductor means materials that allow the flow of charge. Clear? So it can be metals. So this is the basic difference between conductor and insulator. Insulator means materials that do not allow charges to flow through, whereas conductor, materials that allow the flow of charge. Now you have seen a wire, right? A wire. So a wire would be something like this, and then inside you will see a metal, right? So copper wire, okay? Copper wire. So let's say this is the inside one, okay? And this is the outside. So inside would be a conductor, right? Whereas outside you can just touch, right? Outside the wire you can touch because there is no flow of charge, because that is a bad conductor, right? So that would be insulator. Okay, so that was all about the introduction. Now we'll study about the electric current, okay? Okay, so students, now when we are studying about electric current, current electricity, it's all about a flow of charge. Now there are two types of charge that you know, that is positive charge and then negative charge. Right. Now a body, okay, a body loses electron to gain a positive charge. Clear? See, without this plus and minus, there won't be a flow of charge, right? There won't be current. Now, so a body loses electron to gain a positive charge. Now, what about this negative charge? Accept electron to gain a negative charge. Clear? So students, see, taking means minus, okay? But when I am donating, okay, means that is a positive. You think it in that way, okay? Positive charge means a body loses electron or donating electron to gain a positive charge. Whereas for negative charge means I'm taking, so that is a negative charge. Now see, this is physics, but let's go back to chemistry. Now in the periodic classification, we have studied about sodium, right? Sodium, since it has one electron in the outermost shell, what the sodium, it donates this electron, right? So whenever he gives one electron, he gains one positive charge. So sodium becomes, after donating the outermost electron, sodium gets one positive charge. And magnesium, since magnesium is a metal, okay, metal, and sodium is also a metal, and metals, they are good conductor of electricity. Clear? Magnesium, it has two electrons in the outermost shell. So magnesium donates these two electrons. So whenever he donates two electrons, I'm getting two positive charge. So after donating, magnesium becomes Mg2 plus. Okay, why? Because he has donated two electrons. Okay, now that is how, you know, like that is all about this positive and negative charge. Clear? Okay, so students, you can note down this one. Clear? I'll give you a example, okay, which is mentioned in your textbook. So for this positive charge, you can write a glass rod, okay, glass rod. Okay, glass rod, you can imagine any glass rod rubbed with silk. Then you will gain a positive charge. Now this one, and ebonite rod rubbed with fur. Okay, then you will get a negative charge. So this is just an example. Now we'll discuss about the electric current, okay, electric current. Okay, students, distance means it's about speed by time, right? So same as electric current, okay, electric current is represented by I, okay, electric current is represented by this I. So electric current means flow of charge, okay, rate of flow of charge per unit time. How we are getting this electricity? Because of the flow of charge by the time. Same as like for distance, we take for distance or for speed, we measure it in terms with the time, right? So same as even for electric current, it is rate of flow of charge per unit time. Okay. So for definition, what you write is electric current is defined as rate of flow of charge in a cross section wire, okay, in a conductor or insulator, conductor. Okay, rate of flow of charge through a cross-section wire in a conductor per unit time. Okay, so whatever amount of charge that is flowing with respect to the time in a conductor is known as electric current. Okay, now students, electric current, like I have said, it is represented by I. Okay, I. And charge is represented by Q. Okay, see, electric current is represented by I and charge is represented by Q. Time is this one. Okay, so this is how it is represented. Now you will see, when you see the textbook, you will find I, Q, T and all, right? So don't get confused. I means that is electric current. Okay, now Q means that is charge. T means time. That you all know. Okay, now SI unit you have to know. Okay, whenever we will be solving a lot of numerical in this chapter. So whenever you write a numerical, you have to show the unit. Without the unit, even the examiner will not be able to differentiate, okay, what number you're writing. Okay, so we have to show the unit. Okay, so SI unit of current is ampere. Okay, ampere. This is the SI unit of current, and that is ampere. Ampere. Okay. So students, see, we'll say like 10 current is flowing. We never say 10 current is flowing, right? Or we never say 20 current is flowing. We'll say 10 ampere. Okay, 10 ampere. A means ampere. Okay. Now let's discuss about this charge. SI unit of charge. Clear? So this is for electric current. Okay. Now SI unit of charge is coulomb. COULOMB, and it is represented by C. Okay. Now we'll say if it's like 15C. Okay, that means this we are mentioning about the charge, and it is the SI unit would be coulomb. And while writing, we'll just write C. Okay, so C means it is coulomb. So this is the simple formula. Okay, so whenever we have to calculate the electric current or charge, we'll be using this formula. So that means current is equal to charge by time, right? And if you are asked to calculate the charge, what you will do? That's very simple. We'll write Q is equal to current into time. Clear? So this is the second formula that we get from here. Okay, since electric current is whatever the rate of flow of charge by time, right? So from here we get another formula, that is Q is equal to current into time. Okay, so using this relationship we'll solve a simple numerical. Okay. Okay, so students, this is a simple question. The question is a current of 150 milliampere. Okay, see, milliampere. So like meter, kilometer, right? So this one, they have given milliampere. So we will convert this one into ampere. Okay, so see, a current of 150 ampere. That means I. Our I is 150 milliampere. Okay, now next thing, that is 2 minutes. Clear? See, flows through a circuit. That means a current is flowing through a circuit for 2 minutes. That means this is the time. Clear? This is the I. Now, find the amount of charge that flows through the circuit. So they are asking what? Find the amount of charge. They are asking Q. So just now we have studied one relation, that is I is equal to Q by T, right? So that means we have this value, right? We have this value that is here. we have to find this one. This is what we have to find. But students, in numerical, first thing you have to be careful is you have to convert, okay? You have to convert. Now, I, okay, given I is 150 milliampere, right? So we have to convert this one into ampere, okay? Now, it is same with the meter, kilometer, okay? It is same with meter and kilometer. If they have given this into milliampere, we'll convert this one into ampere. Now it is already ampere, okay? So you can note this one down, okay? Now 1 ampere is equal to clear. So now we have already converted this one into an ampere. Now time. Time is 2 minutes. 2 minutes. But we'll always convert the time into seconds. Okay. Now see, electricity, every second it's very important. Okay. Millisecond, the rate of flow of charge. So we have to convert this one into seconds. So that would be 2 into 60, okay, 2 into 60, so we'll get 6 to 12, 120 seconds. So we have everything now. We have this 120 seconds as our time. We have this 150 milliampere as our current. Now we will substitute and we'll get the answer, okay. So I will continue here, okay, here. Now our Q is I into T. Since we have to find the charge, right? And we can multiply this one, I into T, current into time. So Q is here. Now I is 150. 150 into 10 to the power minus 3. Clear? By 120. 120 seconds. Clear? Now, students, you can multiply this one. Okay, we will multiply this one and then you will get 18. Okay, you will get 18 because this minus 3 here can go as like this. So we'll have, if you multiply 150 into 120, you will get like this. So we can cancel this 30, so we get 18. Clear? So charge is 18. SI unit of charge is coulomb. Clear? So this is our answer. So now you have to remember is when the current is given as milliampere, you have to convert into ampere. Okay? For that, you just have to multiply with this one to convert milliampere into ampere. Now time should always be in seconds. Clear? And then the first step, be very careful with the conversion and follow the relation, and that's how you'll get the answer. Okay? So like I've said, this physics numerical, these are very simple. Only thing you have to know the relation. Okay? And if you know the relation means you also know the definition. So that is all for today. We'll continue with the next interesting part in the next class.